My good students, it's another interesting time, also interesting lesson that is going to be. Just want us to go through something on the equation of a circle. Want us to find out how to come up with a general equation of a circle, how to solve equation when you're given the center and the radius of a circle, and also how to find the center of the circle and the radius whenever you're given the equation of a circle. So let's start with the derivation of the general form of an equation of a circle. And I want us to consider a circle of radius r and its center being AB. Now, again, I also want us to consider another point P, which is actually on the circumference of the circle. And then from the point P, B and A, we can form a right angle triangle and then try to use the Pythagoras theorem to solve it out. So from the diagram provided, see that from A to B, that distance is going to be x minus A. And then from B to P, that distance is going to be y minus B. And for this case, you are going to realize that the radius of the circle is taken to be r. Now from the triangle, as I've said, AP equals to R, AB equals to X minus A, and PB equals to Y minus B. Now using the Pythagoras theorem, we therefore have X minus A squared plus Y minus B squared equals to R squared, where now A and B are the center of that particular circle and R is the radius of the circle. Now this becomes the general form of any given a circle on the Cartesian plane. So if you have to find the equation of a circle in any format, then for that case you are going to use x minus a squared y minus b squared equals to r squared. Remember, a and b are the center of the circle while r is the radius of the circle. Now example, I want us to master these two examples where you are given the center of the circle and the radius, and they want you to find the equation of that circle. So the first one is center 0, 0, radius 2, and the solution is a quick one. Recall the equation, the general equation of a circle, which is x minus a squared y minus b squared equals to r squared. The next step, substitute those given information. So we'll have x minus 0 squared plus y minus 0 squared is equals to 2 squared, which reduces, if we are to expand, reduces to x squared plus y squared equals to 4. Example 2, you're given the center to be 3, 2, the radius to be root 5 over 2, and on a quick note, the solution, again recall that the general form of the equation of a circle is x minus a squared plus y minus b squared equals to r squared. The next step, we substitute. You are going to have x minus 3 squared y minus 2 squared equals to root 5 over 2 squared. By expanding that one, we end up with x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals to 5 over 4. Now, simplifying that one and putting the like terms together, we end up with 4x squared minus 24x plus 4y squared minus 16y plus 47 equals to 0. In most cases, the equation of a circle is equated to 0, so you can take everything to the left-hand side. I do believe the two equations are enable you to understand how to find the general form of an equation of a circle whenever you're given the center and the radius. The next two examples, I'm going to provide a demonstration on how to find the center of a circle and of course the radius of a circle whenever you're given the equation of a circle. Now, the question goes, find the center and the radius of the circle given by the following equation. So the first one, x squared plus y squared minus 2x plus 4y minus 11 equals to 0. Now, it's important whenever you are solving this equation to ensure that the coefficient of x squared and y squared is 1. For this case, because it is 1, we are going to pair up the x together and the y together, and then use the completing square method to solve that one. By pairing up x and y together, we get that x squared minus 2x plus y squared plus 4y equals to 11. Notice the x are missing part C and the y's are also missing part C. So we are going to employ the completing square method in equation 1 to find that value of C, where we know that C is b over 2 squared. And therefore, by so doing, we are going to have x squared minus 2x plus negative 2 over 2 squared plus y squared plus 4y plus 4 over 2 squared. And then what we are adding to the left-hand side, we also add it to the right-hand side. So we are going to have 11 plus 1 plus 4. Remember, negative 2 over 2 squared is 1, and 4 over 2 squared is 4. Then we factorize, or equation 2 reduces to, after factorization, it reduces to x minus 1 squared plus y plus 2 squared equals to 16. Now you can imagine that this one looks exactly like the general equation of a circle. And from here, we can see that from that equation 3, we can see that the center now comes to 1, negative 2, and the radius goes to 4 units. Example 2, we have 4x squared minus 12x plus 4y squared minus 8y minus 3 equals to 0. Realize the coefficient of x squared and y squared are not 1, and therefore we are going to divide by 4 to make those coefficients 1, and then we are also going to pair up the value, the x and y's together. So dividing across by 4 reduces the equation to x squared minus 3x plus y squared minus 2y equals to 3 over 4. Using completing square method again, where c is b over 2 squared, we have x squared minus 3x. Then we introduce the part c plus negative 3 over 2 squared. Again, we go to y plus y squared minus 2y plus negative 2 over 2 squared equals to 3 over 4 plus 9 over 4 plus 1. Remember, what is added to the left is also added to the right. Equation 4 reduces 2 after factorization to x minus 3 over 2 squared plus y minus 1 squared equals to 4. Now, comparing this one with the general equation of a circle, then we realize that the center of that circle become to 3 over 2, 1, 3 over 2, 1, and the radius reduces to 2 units. I believe that short presentation has enabled you to understand how the equation of a circle is actually derived and how to use that equation of a circle to tackle some of the questions related to this area. Follow me for more videos concerning the same and more. Thank you, and God bless you for your time.